This is for Year 12 Specialists. It's sheet number 5, the third of the projectile questions that we've done. So this question is very similar to the 2016 trial question that VCAR put out, and it's almost identical. So we have a snowboarder jumping at an angle of theta, horizontal, performs some various tricks and then lands down on a 45-degree. Let origin be 0, okay. So we're being given the position vector as to where the skateboarder is when flying through the air. So therefore, the velocity will be the derivative of this, and I've taken the derivative. The derivative of 6t is 6, of 0.01 t cubed is 3, 0.03 t squared in the I, etc. Now the questions that are asked are, find the angle theta. Well, the angle theta, I can do rise over run, therefore use the tan of theta to be rise over run, and direction is always governed by velocity. So I would like to take the j component of velocity divided by the I component of velocity at time 0, because I want to know the angle when the person left the ramp. So that's going to be 6 root 3 on 6, which gives me 60 degrees. Part B says find the speed. The speed is the magnitude of the velocity at time 0. So of that velocity equation, I'm going to make t equal to 0, and that gives me that. On a calculator, I get 12. And part C says the maximum height reached. Well, the maximum height will be reached at this point here, and at this point here, the velocity component of the j will equal 0. The velocity component of the I will never equal 0, but the velocity component of the j will. So, on the next page, I've said the maximum height is reached when the j component of velocity is 0. Put it on the calculator and I get 5.522 or 5.5 meters. Show that the time spent in the air is this. Well, that's a clue that that answer is going to get used in the next part. So keep that in mind. So when will they land back down again? It's going to land here, and I know that's 45 degrees. So I know the coordinate down here will be x and y, where y will equal minus x. Because it's a 45-degree angle, the gradient's going to be -1. Therefore, I'd like to make the I component of position equal to the negative j component of position. So I've made the I component of the original position vector, the I component of it equal to negative j component. It's 3 marks, so write a few lines, but I got to this on my calculator solving for t. And then lastly, find the total distance that the snowboarder travels. That's the distance along a curve. I have 2 rules. Since I've been given the parametric equation, I'm going to use the parametric equation rule, because this is time 2, the answer that I was given in part D. And this will be the derivative of the I component squared plus the derivative of the j component squared. Since it's worth 2 marks, write the full equation out and then write your answer out.